Yeah, this is where we have seen in the last class, right? Actually, yeah. So in the last class, what we have seen, we have placed the columns actually and walls, retaining walls, everything. We were supposed to discuss for the column location. Leave it actually. We'll discuss in the next class. We'll go for it. I don't want to break this. Okay. So now what happened? So we calculated ourselves the column size actually, and we placed, I mean, even the substructure. How many basements we went for? Edit stories and grid system. Two basement. Two basement or three basement? Three basement. Fantastic. Okay. Three basement. Fantastic. Okay. Okay. Now what I'm going to do? So let us draw the what do you call actually the slabs. Huh? Let us draw the slabs. So define section property slab section. Fantastic. Okay. Can you see my cursor here? Okay. Okay. Can you see my cursor here? Here. There is option called actually draw flows. तुम्हारा नोट था लास्ट टाइम एक दिए थे मोस्ट थे तुम्हारे पास. Okay. Draw flows. Can you see here? Draw flows. Not the perfect rectangular. The one which has a chamfered actually. One which has a chamfered. Okay. Because chamfered and perfect rectangular is what? Perfect rectangular will only pick you 4 points. Chamfer rectangular we can pick you multiple points. Okay. Even if the slab is offset, you can take exactly in the offset actually. You can draw as such you want. Okay. So what I'm going to do, change the property here. So whenever you does this option, change the property here, your relevant property. Okay. For a record. Oh, don't worry, record. Yeah. Then start from here. First, can you look at my cursor? In the left side, there are snap option is there, right? Always try to click first and the fourth one. It's like AutoCAD snap option. Huh? You don't need everything. Huh? First and four is more than enough. Okay. If you try here, can you hear? In the leftmost corner. Huh? If it is not shows, what you have to do, ये है ना, इसमें राइट क्लिक करो. मेरा कर्सर देखो. Here, no? Here, the ribbon bar. Huh? In the ribbon bar, right click. There is a snap is there. Tick. भाई माउस नहीं से तुम यूज नहीं कर सकते. हाँ नहीं, तुम्हारा माउस नहीं से तुम यूज नहीं कर सकते. बहुत डिफिकल्ट है. माउस नहीं. ओके. नहीं, इतना साल हो गया हम लोग भी माउस नहीं से यूज नहीं कर सकते. Really? Go to option. There is option called reset toolbar, right? Reset toolbar. Huh? Yeah, reset default toolbars. Just click it. I mean, you will find the snap option right below, but you have to move it. Got it, right? Anytime if you just made a mistake for the toolbar actually, just go on to the option reset toolbar. It will be like you retain everything. Okay. हाँ वो नहीं बना चाहिए. वो उसको क्लिक करो भीतर नहीं बना. This one, boss. Go to option reset toolbar. Can you see? Reset user default setting. Huh? उसको क्लिक कर दिए तो you will get the snap option here right below in the left side corner. आपको नहीं लग रहा है वो उसको उठा के मूव करके ऊपर रख दो. No, I'm telling in an easier way. If you want to switch on all the snap, it is okay, but you don't need a midpoint and all those things. You don't need. The fourth is what? Intersection. Huh? The first one is actually it is intelligent snaps. It can pick anything. Huh? Corner, edges, it can pick anything. If you're clicking all the snap option, I'm telling you, it will be very difficult actually. While you're modeling, will make difficulties because we'll show all the points. You don't need it. A snap option, like, well, you're been like, what do you call drawing the slabs. Sometimes if you just, wanted to connect to the intersection, then it doesn't show. Even you remember while you're placing the columns also, it doesn't show the intersection. It shows as a cross mark dikhai. Okay, so cross mark kya hai na? Oh, it's a kind of intersection. It's a similar to CAD snapper, CAD snapper. Don't get confused. Similar to CAD, but it is not exactly CAD actually. सही है ना? अंदर है, उसको लेके क्या करो, ऊपर रख दो. तुम्हारा स्क्रीन की वजह से, स्क्रीन का रेजोल्यूशन वजह से वो दिख रहा है. हाँ, स्क्रीन का रेजोल्यूशन है ना, उसको थोड़ा कम कर दिए तो आ जाएगा, बट है. Okay, so what you have to do here, go in the left hand side, there is a draw floor is there, same option. Change your slab thickness in the property. Try to fix at an easier convention one actually. Either you go for clockwise or anti-clockwise. Okay, if you want to go for anti-clockwise since from the beginning, go for anti-clockwise. If you are convenient for clockwise, go for clockwise. But don't mix up the things actually. Okay, always I used to go for anti-clockwise. तो ये किसका मॉडल है भाई? ओके, शायद इधर स्ट्राइट लाइन पे नहीं है जैसा लग रहा है एक्चुअली. या छोड़ दो मुश्किल नहीं चलेगा, छोड़ दो. इट्स फाइन है, नो प्रॉब्लम, नो प्रॉब्लम, नो. या डन राइट. It's fine, leave it. ये सब स्ट्रक्चर है ना, हाँ छोड़ दो. Done right. Any clarification? In the lift there is an opening, right? Yeah, in the lift actually. So we'll model the opening here. Same option, same option, same option. But in the property, instead of slab property, I will choose the opening. Okay, if you scroll down, you will find the opening. इसको थोड़ा zoom कर लो. Can you see here? Okay, see what I'm going to do here, here, here. But just make a cursor very close to the point, then it shows the edge point. Okay, since it is a first interface actually. Okay, just close it, it will show the points. Don't rush through. सही है ना? If you do any mistake, Control Z, undo, then it will come. Control Z कर दो, फिर से कर दो, problem नहीं है. This is center line. Okay. Staircase, most of the people having the confusion. Do we need to leave the opening in the staircase or do we need to model the slabs? Okay. DM को objection नहीं है actually. Okay. Authority, they don't have any objection. Model the slab is much better than leaving the open, because the face slab, waist slab, it is giving like support to the wall. If you leave the opening, the wall, its one side will not have a connectivity, will lead to show the more reinforcement if you don't model it. Ultimately, it is a slab only, because when you talk about the waist slab, it will go like this, it will go like this. But in the plan, if you see, it will be two slabs only. It's entire slabs. You're getting a point actually. In per floor, you'll have mid landing, right? Actually, so two flight actually. In per floor, if you're just looking at it, I mean, you will have a two waist slab, right? Then one slab completely. Entire as one slab actually. Okay. So don't leave as an opening. If you leave as an opening, the wall will lead to more reinforcement because there is no connectivity in this side. Stair will give you like supports. Yeah. Stair will give you stiffness. Stair will give you support. The waist slab. Though you are going to cast, I do understand. Waist slab you are not going to cast at the beginning edge. You are going to cast in a very later stage, or even like when the structure is goes like as such 1/3 or 2/3, you will go for waist slabs. I completely agreed because the core in high-rise building, especially the core will go first, then the slabs, right? Actually, the core will go even 5 floors above than the slabs because of your formwork, jumping formwork, right? Actually, jumping formwork system, the core wall will go above. But still, what I'm trying to say in terms of like the structural wise, in terms of technicality wise, actually try to model as a slab because this will give you the stiffness. This will reduce the reinforcement equals. Okay. You may ask like no, the waist slab is going to come actually. So what I'm going to say you, whatever the load which you're going to assume, wind force and seismic force, this is not going to become in the picture, right? In the initial stage. So once even the dead load, the superimposed dead load, live load, when the building is completed, only it is going to become the entire load which I'm talking about. Correct? Yeah. So try to model the slabs. Leave the opening for the lift because lift is straightforward. You don't have any slabs. Okay. You do have a headroom slab, that's all. But all the floors actually lift is completely open. Yeah. And it's up to you. Either in terms of architectural drawing, it is a panoramic lift actually, then try to remove this wall. Understand, no? Panoramic lift. Panoramic lift is what I mean. One side actually there is a full glass will be there. But the lift is going on, actually people can see, right? It's called a panoramic lift, right? Okay, either only these walls will be there actually, intermediate walls. In both the what do you call face of the wall, it will not be there in the panoramic because either you will see in the outside, you will see full glass. In inside also you will see full glass. Okay. Yes, sir. Okay. You don't need actually because you're making as a complicated. Because at any case, it remains same to just transfer the load to the walls, right? We're only transferring the load to the walls. And we're talking about you're not going to design this category. We are only transferring the load. Okay. If you're modeling landing and base slab as an incline actually and landing, you're making it complicated to the wall. At the end, actually, the loading is going to transfer. Rather than actually just model as a flat. Correct. And if you consider the staircase, this the base slab one and opposite will be not connected to each other. No, but base slab rebar pull over you're taking from the wall. That is for the landing rivers only connected to the. Yeah. But you will not take it the base slab from the pull-out bunch. But still it is connected to the landing, right? Okay. Sorry, yeah, because the staircase is like a cross. Correct. So this and this one will not have. Okay. This level and opposite side will not have. Okay. One is that landing will have that. Okay. So that criteria, how we can. That criteria actually the loading is different only one way you're talking. Right. Step 2 is that diaphragm action. It will not give you that diaphragm action. About that. It will give you only as a sort of stiffness to the wall. That's what I understand your concern because waist slab since it is not connected to the that's not the lengthy wall actually will not take this stiffness. That's what I was saying. The waist slab is connected to opposite sides. And that it will transfer the. Okay, but even if it is not connected, the wall tends to bend actually. This will be the support. Even if it is not connected, say for example, if it is not even connected, okay, but the waist slab it is been like touched the wall, right? Yeah, if it is bent, I mean, it will never bend actually the whole wall. It will only bend between the waist. Support would be there, right? Yeah. Practically, like what we do is the 2 ends of the wall, the river, and the step in between the line. Two kinds of things. One is actually in plane movement, out plane. In plane and out. The out plane is what actually out of stiffness which is going, it is out. In plane is what? The one which is connected to the slabs, it is called in plane movement. Now we are not talking about in plane movement because in plane movement we do have like connections to the slabs. His concern is correct because the waist slabs we are not going to connect it. Isn't it? Only the landing is going to connect. But what I'm trying to say actually, even if it is not connected, if it is touches actually, definitely it will not bend, right? It will bend only between the base level of the wall.
Like some certain of stability in the second.
Yeah. Right? Even if it is going to bend actually, it will bend like this. So the mode, right? They will get the stiffness dimension. It will never bend from here actually towards you. Whole moment. Let me assume the buckling kind of. It will never bend from here to here.
This direction will be around that portion.
Correct.
This
is the landing actually.
Moment that restraint we were considering. So the wall which we are talking that for the base level.
The base level.
Okay, the base level. So maybe in the plan.
This right, this one right. This is the landing right. Yes. This is your talking about now. This is not been connected. Yeah, this is not been connected. So far actually, we did not eliminate to model the slabs. The bit of reduce the reinforcement. We used to model always like two staircases. So if we don't model it, what will happen? Definitely it will lead to model. Not in terms of vertical reinforcement, in terms of shear reinforcement will lead.
Every floor to floor.
Every floor to floor actually we issue. Okay. This only like to reduce the reinforcement. We decided not to model this 100% sure we're getting like bit of height. This is only to reduce the reinforcement.
Basically, model the covered slab. This staircase.
Every floor. Every floor. I'm not even considering the midland. Okay, no. Only every floor. Every floor actually, as such, you do have a slab. Either you go for the same slab thickness or you change the slab thickness. Doesn't matter. Whatever the base slab thickness is there, 200, 220, go for 220. Even sometimes the entire slab thickness will be 260 or 280. But base slabs you're going for only 220 or 240, 250. You can change the slab, doesn't matter. But if you don't model it, okay, it will lead to like moving. This is only the matter of like reducing.
In safe also we do the same thing or only
Safe, we don't consider any kind of walls. Okay, we don't consider any kind of like staircase steps. In safe, we just only like the entire other steps. Again, the staircase which you're going to design it by using any kind of A.E.X.L very important. As to remain the same, we will design it as it is. As it is, we will design it using the A.E.X.L. Because the staircase slab is not going to be give you like that diaphragm action. It will give you on a bit of that. But don't think because staircase slab is going to become like after 1/3 or 2/3. And the structure which is more very important. This is all like only to read the lead. If you connected only, you will get more range. If you don't connect, you will get the less range. Because it's acting as a continuous slab, right? When you're talking about continuous slab, you will lead the more range. When you connected, it will act as a continuous slab, then it requires more range. When you don't connect actually, then it will show less range. Because that is the difference between the continuous beam and the beam which has a end support. If you look at it in the practical actually, for the continuous beam, the top reinforcement is always more. When compared to the beam which is ending at support actually, though you will have like, sometimes you will have a end top support reinforcement. Might have seen end top support. But when compared to this, the extra top reinforcement at the support is more always. When the slab is continuous, Okay, when the beam is continuous, it lead to take the more reinforcement than the slab or beam which is in having the end support. Yeah, सही है ना? But still, again, if you want to leave open, leave open. These are all like been like trying to reduce the reinforcement. You're getting a point. Actually. Some people will lead to try to leave the opening as well. Okay, but it may work only for like 6, 7, 8 flows. It doesn't require like more reinforcement. But when you're talking about really 30, 40, 50 flows actually, okay, then what will happen? First of all, it will lead to have like more shear reinforcement. If you look at it like especially for core wall, it will go for 12 mm dia shear reinforcement, horizontal reinforcement I'm talking about. 16. Sometimes it goes even 20 as well for certain flows, right? Actually. Okay. Then you may say it is wrong. It's required. I'm talking about in terms of structural model to compensate the shear actually. Horizontal reinforcement is mainly help only for the shear reinforcement. To reduce it actually, it helps only because of that. Okay. Just try to model the opening. Huh? Another thing actually, the most interesting thing is what you will be relieved from the application of loading on the edge of the wall. Or else what will happen? You need to calculate half of the landing, half of the step, and you need to apply as a UDL. These are all hectic actually, you can relieve it if you're modeling as a slab. Then you can give us the area load actually. You're getting a point actually. Yeah, you can relieve from it. In a high-rise building, which load is going to be governed to the structure if you ask me? The straightforward question, it is not lateral. It's not a gravity load. The lateral load is going to be governed to the high-rise building. So which is the most important thing? The lateral force. So I need to be like, from the beginning to take care of the lateral force to reduce the rain. Gravity doesn't matter. Even if you're talking about the columns actually, the one which you are using the equation 0.85 FC dash 0.61 FIAST, calculate the column capacity huge when compared to the actual. But the moment when you have been like, adding the lateral moment, actually, adding 3%, 5%, 6%, it drastically increases. So the moment which is going to be lead, which much more reinforcement than the gravity. भाई दो ओपनिंग भी मॉडल कर दो हो गया interesting here actually if you are asked this kind of question it's very interesting because you people are all poor people huh? Yeah, fantastic. And another thing actually, see if you want you can separate this slab, but doesn't matter. Staircase slab you can separate it. It's a differ from the consultant to consultant. No, I'm not talking about releasing the moment. I'm only talking about the application of load. Application of the load according to the code A.E.X.L 7 for the staircase live load is 4.8 kp. Okay, 4.8 kp. Even for the passage is 4.8 kp. Corridor and passage. This is the corridor. The lift lobby. This is the lift lobby. The whole is called as lift lobby only. Actually 4.8 only. It is not 5. It's given in the ACA code itself 4.8. Okay. The reason why it is 4.8, I mean, if it is anything goes more than 4.8, you need to consider into the mass source of 25%. Yeah, it will consider. As long as the node is connected, actually, it will consider as a one slab. If the node is not connected, if you're leaving the gap of 2 mm also, it will not consider as what you call one slab. As long as node is connected, software another. Software edge. With this, you can just still you can reduce the load actually, because you don't need to consider 4.8. You can consider the same loading. Okay. DM utna object nahi karega because in high rise building no one is going to use the staircase. Okay. वो तो खाली ही रहेगा. No one is going to climb up to 50 stories. हमारा बिल्डिंग पे एक्चुअली कब फायर होता है कब if it is like what do you call mock up, mock drill actually पता ही नहीं होता है actually. 3 दिन के एक बार एक्चुअली आवाज आता है, कोई भी उठेगा भी नहीं यार, फायर हो गया. Let them come into my room, then I'll you're getting a point. 40-50 floors under it is unimaginable. You know, people will never like climb up. It's a kind of advantage. Still, if you want to separate the slab, you can model it and you can separate it. While modeling it. Then we can Okay, only for the modeling purpose. That location you got two. Exactly the wall location. எங்க இருக்கு ஸ்லாப்? First, you will be directly exposed. When you don't reduce the exposure change from the area, you will be directly exposed. Okay. Yeah. There are some consultants out there. You can name it as straightforward. They will do the overall design. So the design is very safe. But it is not the point of like no. Design is very safe, but overall the full name is even my last project is considered there will be more about design. That's what finally it helps. Because last project changes and it was still something. Although actually in a very rare case, imagine example, if you have done the design, okay, you're not going to represent, right? As a consultant is going to represent, right? Over X, Y, Z. X consultant, Y consultant, Z. Marketing actually, okay, what do you call it? It's called shield this actually value engineering consultant. Okay, we know most of them. Okay, and they do have a huge connection with the authority. Okay, they can take your design by bit, they will reduce like what do you call it, 8% to 3% from the overall cost, 3%. So if your body will say, for example, 1 billion, 3% is of 150 million. 150 million is not a joke. It's not a joke. 150 million structure period of 40%. Okay, you will say almost 60 million, 70 million, right? 60, 70 million. So you will be directly exposed. Maybe each they just change the name from Tether to I.E.X.L. Same thing you change the name to from. Most of the contractor does it. Whatever the one which is received from the consultant, they won't change it. They will price it as it is. Okay. They will price it and they will go for it. And when it is going to be like stock touching, it's between the client to contractors, right? It won't change. You do the value. And you don't worry, we will submit the OD code. design with the consultant. Let him review. Okay. Overlay actually. Consultant for Shana. We need the take for 15 minutes. 200,000, 300,000. Very information. Not even it is not even like 1 million. Less than half a million I will pay or pick up. Because I know monopoly is only 4 consultants. What is it? Only for third party. If you want to get a third party approval, you need to approach this fourth third party. RBG, these are like a structural specialists. Okay, they are very strong in the structure. Some consultant you can say, Robert Bird actually, WME, and what else actually? Atkins. Okay. These are like structurally they are very strong. Architecturally also. Why architecturally they are not very strong? You will never find like killer design, killer design. Who did the what do you call museum structure? It's a killer, right? The museum, future museum. Okay. Future museum is not been proposed to killer. It has been proposed to multiple consultants. Among them, killer has been selected. Everyone they propose the different concepts. Why say what actually? The competition is like this. The client want to separate this project actually. First they will go for competition. Okay. First they will go for like 3D views actually. You don't get anything like much. Okay. Very slightly, very conceptual design. How many plans here together. But mainly they will only go through like aesthetic. So whoever is going to propose and they will select it. Okay. Aesthetic radically the separate architecture. So these people are structural specialists. Okay. Architectural innovation like I would say this because they are all structural best engineering view. So they are all very research. If anything like complicated structures, you can go. Okay, that means W from the RBG. So these are like most structure. There's anything complicated, we will go for. But architecture, because they will find you will never get like more people. They do it with creativity. Yeah. Yeah. Okay, fine, right? Yeah, here, go to define load patterns. Add just type SDL. Yeah. Define load patterns. Yeah. Then change it to super dead. Change it to super dead. Then add new load. Yeah. I don't know now how it is actually, because I cannot because the one who is sitting from BIST. Okay. Best engineering consultant design is a bit over design. I don't know now actually. I'm talking about 7-8 years back. But they're very safe. And you will get the solution for any complicated structure. Yeah, this one. The dead load, which has self-height multiplier 1 is what I mean. The software itself, whatever you're going to model the structure, since you already feeded the density of concrete as 25, it will calculate the whole own weight of structure. Okay, that is the reason it is 1 H. So one weight of structure, you don't need to add or you don't need to specify anything separately. You're getting a point actually. So what you're going to do separately, superimpose dead load and live load, you're going to add it further on top of the self-weight of structure. Okay, that is the reason it is 1, because it will automatically multiply. But if you are keeping 0, then you need to calculate manually for the self-weight of structure. You have to apply. Whatsoever it is, either you keep 0, but no one is this. Because leave it as it is, because whatever you're going to model with respect to the slab thickness, with respect to the corresponding density of concrete, it will automatically calculate the whole own weight of the structure completely. Yeah. Okay. Then what do you call? Yeah, click OK. Yeah. Then select the slabs. Selecting the slab is what? Just click the slab, it automatically selected. Yeah. Load cases is what actually, which you are entering the individual cases. Dead load, SDL, live load, wind load. These are all cases. Combination is what? When you're combining with the factor of safety, actually, it is called combination. Combination is what? It is ultimate combination, serviceability combination, right? Combination is nothing but what? It's combined between like 2 cases or 3 cases. More than 1 cases, it is called combination. But by adding the factor of safety, then you're going to further define by ultimate or service. So that is in combination. Actually. Whatever you're adding, it is not non-linear. It is all linear. Okay. उतना तो मत जाओ अभी पढ़ा है दिल्ली दूर का कहानी we had like lot of things. Don't go into the non-linear now itself. Non-linear is what actually the one which you cannot predict. Okay, if you want me to give you the best example actually, how you are going to do the chain survey in roads chain survey. Okay, if it is like 10 kilometers, when you want to do the survey, okay, if the bare ground there are so many undulation is there, as long as if you don't get the close reading actually, you will never get the actual undulation, right? Then you will never calculate the cut and fill actually. Why you're doing the chain survey? To calculate the cut and fill, right? In the road, isn't it actually? What is, how much is the cut quantity? How much is the filling quantity? That's what you're going to do. Huh? Before the infrastructure, you will do the chain survey. But that is, again, it is a linear rule because you can easily predict it. When that becomes non-linear actually, when there is a huge ground is there, huge undulation is there, or huge drop off is there, if you don't take it close reading, then if you're taking like from this end to another end actually, you are only drawing the approximate curve. You're getting a point. You're only drawing the approximate curve. Then you're not going for non-linear, you're going for linear. Non-linear is the one what I mean. You don't know, like as long as you are taking the reading only, you will get to know. The close reading only, you can draw the non-linear curvature. So these are all non-linear because it is unpredictable when the long-term deflection is going to be happen. Okay, due to deterioration. Because the creep coefficient is going to be changed. Might be after 1 year, after 1.5 years, after 2 years. The deterioration of the material when it is depends actually, then the creep coefficient is going to change. The maximum creep coefficient is 2. Maximum creep coefficient is 2. But between these two only it is going to play. 1, 1.1, 1.2, 1.3. What does it is very simple, I'm telling you, it is very simple. You are going to reduce the modulus of elasticity of concrete by having some reduction factor. That's it. The modulus of elasticity is what? 4,700 multiplied by root of FC dash. Right? Okay. This is the fresh concrete. New concrete. 100%, which is the strength attained concrete. When you are going to multiply the reduction factors, then automatically strength will get reduced. The one which you are going to use the modulus of elasticity as 4,700 for the fresh concrete, the deflection might be 10 millimeters. The moment when you're going to apply the reduction factors, the deflection might be 20 millimeters because you reduce the strength, right? You reduce the grade of concrete. You get a point. You reduce the grade of automatically deflection will be higher. Reinforcement is same. You're not going to reduce the reinforcement. Huh? Reinforcement is same. Section sizes is same. After 5 years, actually, are you going to reduce the range? No. Still the same reinforcement, still the same section size, still the same effective depth, which is not going to be changed. Only the material reduction factor which is going to play around to increase your deflection, to increase further deflection. Same human body, when you're standing actually after 50 years, actually you will bend, right? You will bend because of deterioration. If you're standing, then your deflection is more, right? Okay, solve. Same. Okay. So just click the slab. Yeah. Assign shell load. Shell load uniform. Only uniform. Huh? Only uniform. Change into SDL. If you decided it is only like, car parking, there is no finishes. There is no finishes. The DM will approve the loading of SDL 1 to 1.5. 1 to 1.5. Even we got the approval for 1 as well. Even we got the approval for 1.5 as well. There won't be any kind of loading. Because in car parking, there will be directly fair finisher. There is not even screed. Huh? There's not even tiles. You're getting a point, actually. So bare slab, it's only what fair finish, right? Actually, what do you call it actually? Epoxy coating. That's it. One is more than enough, huh? Because one is you are imposing 100 kg per square meter. Huh? Further, for MEP itself, it is only 30 to 50 kg. Huh? Still, you are considering 50 kg more. Huh? Remember? Huh? So one, okay. How you are reselecting the slab? Can you see my cursor? There is an option here called previous selection, PS. Huh? If you're clicking here, automatically it will select the previous. Huh? Here, the left side, huh? PS. Huh? PS. Then you don't need to select again. Yeah, because you might have selected multiple sections. You're getting a point. Actually. Then you don't need to go and select which one you selected. Actually. Then this one will automatically give you the intimation for the previous selection. Okay. Yeah. Assign. Yeah. Assign. Shell load. Uniform. Live load. What is the car parking load here? 3.4. Only for saloon cars. Someone asked saloon cars. No, not here actually. Telling other saloon cars is only for like what do you call it? Sedan actually. It's not been like for four-wheel drive. Saloon car in the sense including four-wheel drive. Including four-wheel drive. No, it is in live load. Assign, yeah, shell load, uniform, it is in live load. It is in live load. Yeah. What is the question actually? Someone has asked the question. Yeah, reason why I didn't explain this three option, you will get confused in the beginning. Okay. But still, the keep always replace existing load because you're not much familiar in the ETABS model, right? It might lead to like, do several mistakes because the moment when you add to existing load is what? Instead of 3.5, you want to add 5. Then what will happen? You can add only 1.5. You can use this option, add to existing load. Then becomes 3.5 plus 1.5, automatically it takes 5. Okay. But if you forget to select this option, if you replace, then instead of 3.5, it becomes 1. Okay. Since once you are familiarized, actually don't use it. Don't use this. Up till now, we are not using it. Then. Okay. Because anytime, like, by careless, it happened the mistakes. It goes even over design, it goes even under design. Who knows? Okay. Delete existing load, you know that. So if you want delete it, delete it. Okay. Say, na? Okay. Fantastic. Now what I'm going to do, okay, I will take it. I will just select this to selection. Remove this line. See, I'll tell you here. So I selected here, right? Okay. For unselect, don't do undo. Control Z actually. If you do Control Z, everything will go away. Can you see my cursor left side actually? There is an option called CLR. CLR. Click CLR, the selection will go away. Yeah. Don't do undo. If you do undo, you don't know whatever the command which you are used previously, it all go. Even the application of load also will go. How many times you do undo? How many times it will go? Okay. Sometimes the redo will not come because where you save the undo, like 3 options before actually, if you save it, then only it will stop there. Actually. Then further 3, 4 command, you will not get it. Okay. It's good to not use control S like AutoCAD always. Until otherwise, if it is stuck, okay, but that is a different story. But if you're using control S, if you want to do undo and redo, it will stop there. It will never carry forward like 3, 4, or 5. That happens, huh? Okay. A big guy, he said the right things. Can you see these lines actually? Yeah, small lines. Huh? That we took it as a dummy reference line. Huh? We will delete it. How can we delete it actually? Go to select. Yeah, object type. Can you see the option called null lines? Yeah. Select, close. Select, close. Yeah. It automatically selected all the lines. In the keyboard, actually, use the delete command, delete it. Yeah. Correct. Yeah. Go to select. Whoever it has not been successful, just what do you call, click the clear selection, CLR. Then go to again select. Yeah. We don't need for beams, right? We don't need. Okay. Object type. Quotation, quotation, jaldi भेजो quotation. Yeah. You need to change your laptop. The time to change your laptop. Now, when you are going to buy the laptop, actually, try to buy like 32 GB. 32 GB. Yeah, don't go less than this, because now you are getting like good laptops with high configuration. If you want to go for a very bit higher side, actually, go for the A.E.X.L laptop. I have seen one in Jumbo or what is the other? Sharaf DG actually. 18,000 actually. It is a glossy, high configuration. 18,000, high configuration. High configuration. No, my laptop is, what do you call it, home. This is my cousin. No, mine is high configuration. Mine is workstation. It's not laptop. Workstation, because we don't have a system. We directly connected to HDMI cable actually. We don't have a PC. Okay. What will happen? It will act as a workstation. Even if you just, leave it for 24/7, it's like a PC. But laptop, you cannot leave it for 24/7, right? Actually, because it will be heat. Then you need to keep always the cooling pad actually, or you need to leave for 4, 5 years, 15, 20 minutes, like, rest. Workstation, you don't need it. Workstation, it will be high, bit expensive. No, but if you're decided to use multiple softwares, not only ETABS, like multiple softwares, like, then go for high configuration. But you don't need 18K. Section properties, frame section. The same beam, how you, what do you call actually, created the beam, add new, or no, don't go for add new property. No, add copy property. You already have the beams, right? 400 by 900, right? So use this, add copy of property. Same option, huh? We're not going to change it, huh? Yeah, now it is not 400 by 900. SB 300 by 1400. Fantastic. Yeah, practice karo yaar. Practice nahi ki actually. Every time it looks like new only, yeah? Yeah? Every classes actually it looks like new only for you. Then it will be very difficult for you, huh? फिर बहुत तकलीफ होएगा यूज करने में. Then click OK, yeah? Whoever finished, I mean, here, whoever finished actually. Here, can you see my cursor? First, second, third option. There is a line is there, right? Click this line. Yeah. Click this line. Change the property to SB. If you scroll down in the keyboard, type S automatically it will find your property. Yeah. Then here. Can you see? What is the wall thickness? Khalas, then 300 by 1400. Whatever the wall thickness is wall thickness. Here. The modeling is between here. This to this. That's it. But Sharjah municipality is a bit crazy. They will never allow us to model from here to here. They will ask us to model 50 times of diameter extension. You're getting a point, actually. Because when you're extending this spandrel beam, you're not going to stop exactly at the door opening, right? You will extend 50 times of diameter, isn't it? Huh? That's only the rebar. That's what I'm talking about. Same rebar you're extending, right? But you're getting some kind of stiffness, which they are telling it. You want us to extend it. Extend the beam of 50 times of diameter. They'll ask us to model like this, only in the Sharjah municipality. Yeah, wall pe overlap bhi ho jata hai, because it will overlap in the model. It doesn't work in the model. It doesn't affect it. I'm telling you, because when you're applying, when you're going for Sharjah municipality, you may face this problem. That's what I'm telling you. Because we face the problem. Purposefully want us to model. And when there actually we modeled, we shown the difference, there won't be any difference. We said, no, we need it. Then the meeting was cancelled. We took it back. Actually, we modeled everything and we went back. Because it's not easy, like, one beam actually to model and then there actually for 10 minutes. So it's for tower actually. Then we took back actually. We just model everything. There is a guy who's been there actually. He's a favorite of Mr. Karthika. Sakkar, huh? Muhammad Sakkar is a very favorite of Karthika. He left, right? I heard. Huh? He is good also. He will be complicating us. So we apply the load, right? Actually, so we select the slabs. How do you select actually? Just drag it and select it, yeah? Hey, everything you just select. Beam properties, we did it, no? Beam. You did it, right? Between exactly in the door opening. Yeah. Similar, no? Even staircase also similar, right? Actually, on top of door opening, you do have spandrel everywhere. Huh? See, if you think it's a panoramic lift, actually, then it will not be there. Because in panoramic, full glass will be there. Only steel beam will be there. Okay. In that case, you cannot add it. Concrete will not be there in panoramic. Huh? And such a deeper for 1.4, 1.5 in panoramic, and no one will agree. Huh? Might be steel beam will be there. Glass steel connect ஆகும். என்கிட்ட கேளுங்க, எனக்கு கொஞ்சம் மலையாளம் தெரியும். கொஞ்சம். Okay, yeah. Just select this. Huh? Yeah. Then go to edit. Replicate. Huh? Story. Yeah. Story. Which slab you selected? B1, right? So don't select B1. B2 ground floor. Oh, only 2 floors. Huh? Or what you do? B2 ground floor story 1. Huh? 3 floors select. Huh? B2 ground floor story 1. Huh? You can drag it directly in the mouse. You don't need to select the control. Just drag it from the mouse. Yeah. Then click OK. Whatever it is, whichever is easy for you, select it. Huh? Don't give importance to the modeling. Huh? Give least importance to the modeling. If you give the more importance to the modeling, then you will be like, giving a big gap for the structure. Okay. Don't think. Huh? Consider we are not architect. That's it. I need a model. That's somehow we need it actually to extract the results. That's how you need to. If you think like, in a way of modeling, then you will become more fond of architecture. Then you will never come out, I'm telling you. Okay, then you will lead always perception, actual and accurate. Okay, that's not our core. Yeah. And go to B2. How do you go to B2? Can you see the arrow mark up and down? Okay, if you click the up arrow mark, it goes next slab. Huh? It goes next slab. Then go to the next arrow mark, it goes to the next slab. Okay, so up to ground floor, it is the same, huh? Similar. But fortunately, in ground floor, it is not the same loading. Consider there is no car park. Okay, consider. I do have the car parking only two. In the ground floor, consider I do have like, what do you call the commercial restaurant or kind of things. Okay, so what will happen? I'm going to change the load. Just select the slabs, assign, shell load, uniform, change it to SDL. How much here? SDL? Yeah, Rohit, how much SDL? You have seen the last class, how much? 5, right? Right? 5. 5, you know that, right? 4.8, which you have given the calculation, but 0.5, I told you, like, okay. Then again, select the slabs, assign, shell load, uniform, live load. Consider it is a commercial purpose. Huh? Okay, might be in the ground floor, there is offices. So consider 3. Eh? Yeah, for office, it is 3, right? Actually. Loading is main important. Huh? Take a little more time while applying the loading. Because if you do any mistakes in the loading, it will impact in the results. Take just few concern while applying the loading. That's all. The structure is very easy. How you have been like taken into the consideration. That's what. If you're taking as a complicated. Structure नहीं है. For be complicated. सही है ना? Line draw करना भी complicated. Great. If you take it in light way, that's it. You go to any structural engineer actually, when you say changes, I mean, they will never react anything. Okay, you just go and change, tell these changes to architect, they will react so much. Oh, why? Structure will never react. Structure will say only, we need time, that's it. Okay, when do you, next question they will ask, when do you want to submit? Okay, no, we need 2 more. You're getting your point actually. Structure will never react actually, as a kind of hot core. So there is intelligence, okay, give me the plan. No, that's how, you need to tackle it. Because we are not architect, we are not modular, we are not like, CAD people. No. We always think in terms of technical. What are the changes which will have an impact? That's it. Okay. Select this ground floor. Make sure every time when you do selection, make sure it's a CLR. Huh? Nothing has been selected. Huh? When you click the CLR, if it is hidden, then nothing has selected. Okay. Make sure that. Huh? Because might be sometimes while mistake actually, any points, any column has been selected. It appears, say, for an example, I have selected one column. So CLR is on. So we don't know, like, so just make sure CLR is hidden and select this ground floor. Okay. Yeah. Only one story. Edit, replicate, story, only story one. Really? Oh, wait, fantastic, fantastic. Then go to story one directly. Yeah, very good, very good. Then go to story one directly. And the upward arrow mark. Very good, yeah. Umar ho gaya. Yeah, we'll change the look. Huh? This is story one. Now, what I'm going to do, okay, here, huh? What I'm going to do, I will remove the wall, even the slabs as well. Huh? Wall is what? Wall is only in between the retaining wall. Huh? Because I'm talking about story one. Huh? Up to ground floor, the retaining wall will continue. Ground floor in the sense what? Retaining wall will go down. Huh? That's how the software will treat. Huh? If it is ground floor, it's nothing but below basement to ground floor. Okay. So in story one, delete all the retaining wall. Huh? Yeah, gone. Let it be because I'm going to model the beams. Huh? Yeah. I will model the beam here. But the problem is Fantastic. Yeah. सही है भाई. Okay. I'll model the beam. How the same option draw beams change into what? The B 400 by 800 you do have, right? Yeah. So model the beam connecting to the column to column. But here as well. Here as well. Yeah. Don't model it on top of wall. Huh? On top of wall. It does not read. Huh? No use. Huh? I haven't modeled anything on top of wall. Huh? Only a model in between. Huh? Just have a patience, huh? Because in an initial way, in a very starting in the modeling, you'll be like, bit slow. I know that. But when you practice, that will go on. Huh? Whoever finished, try to model the slabs. Huh? While you're modeling the slabs, change the property. Yeah. Yeah. Change the property. Make sure bit of patience what you're doing. Yeah? So don't rush. Just if you're taking a minute, actually, then it will be easy for you. Intersection कर दो दिख जाएगा. इंटरसेक्शन में दिख जाएगा नहीं तो फर्स्ट स्नैपशॉट में भी दिख जाएगा. थोड़ा जूम करो दिख जाएगा. अंदर लो पॉइंट अंदर है ना. उतना जूम करने की जरूरत नहीं है. थोड़ा और कम कर लो. बाहर नहीं दिखेगा. सेंटर लाइन है ना, पॉइंट अंदर ही दिखेगा, बाहर नहीं दिखेगा. Yeah, done right. Whoever does change the loading, select the slabs, assign shell load uniform, change into 5, yeah, which is HDL. Then live load will be 2. Fantastic. Yeah, very good. Great. Isn't doubt. No, what happened? People is been like taking a wrong perception that actually I finished the modeling. I've done the modeling. If it is 100%, give only like 10% for your model. 90%. You was a designer. You was a structural engineer. Loading you need to apply. Yeah, just click the slab, right click. There is option called load. You will see the loading. Yeah, you will see the loading. Right click. The loading, it shows how much load you've been applied. Even if you haven't applied, it doesn't show. Yeah, fantastic. Now let's say I have a cladding. Glazing in the peripheral. It's full of cladding. The cladding load minimum will be as per DM is 3 kilonewton per meter, 300 kg per meter, including mullions and everything. If you don't want, I will give you the calculation for the cladding. What is the glass thickness you're using for glazing? 8 plus 6. Okay. So 8 plus 6 will be 14 millimeters, right? What is the density of glass? 25, which is equal to concrete density, right? Do it. 0.014 multiply by 25. Multiply by what is the floor height actually? 3.6, right? Yeah. How much? 1 point? 26 multiply by 10 to 15% extra, 10% only. Mullions, huh? Transoms and mullions supporting aluminum structure, 10% extra. Multiply by 1.1. How much? कितना है? कैसा आएगा? उतना ही आएगा? हाँ, खलास 1.5 then. Okay. In a real calculation, it comes 1.5 to 2. If it is 8 plus 6, say if you are going for 9 plus 9, differ glass, right? Actually, maybe you're going for spider glass, then the glass thickness will be more, right? Actually, okay. So DM is going for a higher end. Actually, go for 3 kN per meter. Okay, but glass cladding, including only that's what you're taking 10 to 15% extra mullions and transforms. That's what you took it like 14 millimeter for glass for the density. कौन है actually? Aluminium है ना? Aluminium lightweight है. कितना आएगा? 1 square meter में ले लो actually. सिर्फ like you know 2 transform आएगा, 2 mullion आएगा 1 square meter में if you take it. Realize. Yeah, 3. You need to consider 3. कैसा consider करना है देखो भाई. इधर देखो. While you are applying the load on the beams, actually, you need to select the beams and don't go for precisely to select the beams. Just, you know, randomly select it in the beams. Even the slabs will select it, doesn't matter. Huh? Because when you're applying the UDL will never act as a slab. It will act as a member only. Okay. Even if the slab is selected, don't worry. Huh? Even the wall is selected, don't worry. Huh? सही है ना? But column को select मत करो. है ना? Assign, yeah? Assign, huh? Frame load, distributed, SDL, here in the last number, 3 kN per meter is the last number. Yeah. Yeah. But here in between, there is a trapezoidal loading is there, right? That if you think you need to apply as a varying loading up to 0 to, say, for an example, 50 centi one loading, from 50 centi to 1 meter one loading, from 1 meter to 2 meter one loading, then you can use it. Okay. Or else you can go for uniform load. So, and that's it. Okay. Right? It's not minus, huh? It's automatically in the gravity, huh? Positive only. Huh? सही है ना भाई आप सिविल इंजीनियर आईटी है भाई सिविल इंजीनियर माउस नहीं से यूज कर रहे ना इट लुक्स लाइक सो इंटरेस्टिंग because with IT people only they will just we will never use it. Our people like we will just only looking for a mouse. Yeah, mouse word use करना mouse there. Yeah, we need it. When you're seeing IT guys actually. Yeah, they'll only use the keyboard on this. We'll never use it. Our bhanja ek banda actually IT है. Almost नीचे है. वो लेके इधर बैठ जाएगा. Oh really? Really? Very good. But तुम देखना पड़ेगा ना. You have to. But you have to see, right? Actually, but you will memorize. Very good. Yeah. Control C, Control V. Yeah. I told you, hard work actually. This is actually the best thing for mouse का नाम क्या है भाई? काम पे लिए? मुझे पे दो, हाँ? मुझे भेजो, मुझे भेजो, हाँ? Very good actually. Even if your email can make as a shortcut, write the email ID, assign it as one, then if you click one, then your full email will type. They are all right backward actually. These two people know. These two. When these two guys know actually, that's the reason he was sitting very close. Huh? One is for me to उसको देखे मुझे civil engineer लगा रहा ही नहीं because he was very fast while using like I'm noticing he was very fast. He's not slow. अच्छा जोड़ी है दोनों का. Very good. वो देख रहा है, वो अभी भी उसे मुझे चाहिए नहीं, वो अभी भी बोल रहा है। Yeah, assign frame load distributed, चलो distributed. या दोनों में ना सी सेम ही है भाई, एक्चुअली ये दोनों भी सेम ही है, देयर इज नो डिफरेंस एक्चुअली। ओके, ये भी सेम ही है एक्चुअली। इधर तुम डिस्टेंस दे सकते हो। ओके, इट हैज गिवन लाइक डिस्टेंस एंड लोड एक्चुअली। दिस इज आल्सो सेम। ओके, सेम सेम। So can we go for it? Yeah, it's finished, right? Okay. अभी 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 क्या करो, story 1 को select कर लो. But you know, like, while you're selecting, make sure CLR is always hidden. Huh? Yeah. Then edit, replicate, story. Which one selected? Story 1, right? From story 2 से लेके ऊपर तक पूरा drag कर. Yeah. Story 2 to till roof. Huh? Yeah. Then okay. Huh? Correct. Yeah. Now, still you are in the command only. Like AutoCAD, actually, when you're using the command, you will use the escape key, right? Actually, when you're using the escape key, you will come out from the command. Here, to come out from the command, you can still use the escape key, but it shows the number, right? 3 kilonewton per meter. In the sense, it is still in the command. Actually. Display undeformed shape. Display undeformed shape in the sense what? You will come out from the command. Okay. When you click display undeformed shape, you will come out from everything. Then there is an option called, what do you call, 3D. Click 3D. There is an option called 3D, right? Yeah. Okay, right? Yeah. Yeah. Correct. Yeah. So now what we are going to do, we'll apply the wind load as a diaphragm. So go to define. Define. Yeah. Load patterns. No, don't go for it now. Don't go for it. I'll tell you first. We will assign the diaphragm. Go to select. 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 Object type. Floors. So here what will happen? Entire floors will be selected. Okay. Then select close. Yeah. Right click on the screen showing like, show selected object only. Yeah. Entire slabs. Now what I'm going to do, I'll do the diaphragm action. Okay. So go to define. There's an option called diaphragm. Modify. There are two kinds of diaphragm is there, rigid and semi-rigid. It will never be called it as rigid actually. Okay. Always structure to structure is semi-rigid. Rigid is nothing but you need to change the detailing. I told you, right? Actually. Okay. The detailing will be what? From beam to column. Then when there is like, high seismic is there, the beam top reinforcement, they will embed it into the columns. They will take into the columns. Now what you're doing actually, you will only stopping on top of column, right? Actually, as a L bar, only for LD. You need to take it for the high seismic zone. The detailing is entirely different. Then it will be considered as a fully rigid. LD will increase it. When there is a high seismic like zone 5, zone 4, zone 5 actually, which is like a high seismic, only for detailing is different actually. Or else you cannot call it as like, completely rigid zone. It's only semi-rigid zone. Rigid zone, what will happen actually? It controls the entire deformation. Now what happened? The building is flexible. So your designing building is flexible. The semi-rigid. Still remains same. That will be remain same. That is only after LD, you will taking like further 50 times of LD. 50 times of LD into the columns. Another 50 times of LD into the columns. To make it rigid. Nowhere is using except where there is such kind of detailing is required anywhere with the specific country for the high seismic zone. There we are using. We haven't used up till much. We haven't used. Yeah, like zone 5, there is a high seismic is there, like Indonesia, Japan actually. Somewhere, if the authorities is required, even you don't need to use it. Still, if the authorities is required. Okay, okay, okay. Then select the entire slabs here. Just drag it and select it. Assign shell. Yeah. Diaphragm. Yeah. D1. Okay. What is diaphragm? Already told you, right? It defines what? CR. It defines what? CR. CR is what? Center of rigidity. Center of gravity is different. Center of rigidity is different. Center of rigidity where you are going to take the lateral support system. The lateral support system, wherever there is a huge stiffness is there. Where is the mass stiffness is there? Where is the moment of inertia is more actually, which is being core wall. So center of rigidity automatically it will be like towards to the core wall. It will never be exactly in the CG of the building. Okay. So I'll show you now. Then go to any plan, any floor you can select it. Yeah. So this is the wall location, right? Now you cannot see. Right click on the screen, show all objects. Can you see here? The CR, center of rigidity, which is close to the wall. Actually, CG is here, somewhere. Where I'm keeping cursor, this is the CG of the building, right? Somewhere here. But CR is what? Center of rigidity, where the lateral stability of the system is located. This is called CR. Diaphragm is going to create the CR, center of rigidity. Okay. Now, let us remove the unwanted points. How to remove the unwanted points? Keep into 3D. Okay, keep into 3D. Yeah. Select everything. Yeah. Select. Now, before selecting, actually, look at this point here, joints. Can you see here? 1032 joints will be there, right? For me. Fantastic. 1032 joints. Okay. No problem. For you, actually, if the joints is less 2-3 is fine, actually. The 1032 joints is what actually how you are going to connect it. Okay, this is the joints, where you are going to connect it. Now, what I'm going to show you now, we are going to remove the unwanted joints. Some unwanted joints are there actually. It will be like, fine-tune the model, which to avoid any kind of warnings and errors in the model. Okay. So select everything. Select, deselect, not select, deselect. Yeah. Object type, deselect. Here, what are the things you need to just deselect? Columns, beams, floors, and walls. That's it. These are the 4 elements is there, right? I'm only talking about the points. I'm not talking about the opening also. Fantastic. Opening also. Very good. This 5 items only. You only model the 5 items. Bottom, deselect, close. Yeah. Still 1032 joints is there, right? Use the keyboard, delete it. Now select it again. How much points? So 4 points has been like unwanted points. So those things you need to do, because or else it shows some kind of warnings and errors. Actually. It's a very simple step. Yeah. Display undeformed shape. To come out from the command. Go to plan, use any kind of floor. Go to plan, use any kind of floor. Plan. Here. Go to plan. Just select any kind of floor. Okay. Then go to display undeformed shape to come out from the command. You can do anytime. Display undeformed shape, you can do anytime. Just to come out from the command, like AutoCAD, you're doing escape key. Display. If you want to select the particular story, you can go to plan. You can select the particular story. Anytime. This is not technical. This is like, what we call related to the model. When you're modeling, actually, you will have some kind of extra points will be there. Okay. You don't know.
So we selected this 5 elements and
We deselected. Everything else is what everything actually only points, joints. Okay. If anything unwanted points are there, unwanted lines are there, which you have been like, dealt as it is. So you will remove it. That has to be a will delete it. This is to fine tune the model, not technically. Because you deselected, no. You selected everything, but you deselected all these 5 items. And then it's fine, leave it. You did not delete it in the. It's fine, leave it. No problem. Yeah. Yeah, exactly. This is only related to ETABS. Don't think anything like technically. Technically, we are not playing. We are like, going because you are trusting some third-party software, right? Actually. Okay. So since you are trusting some third-party software, actually, you should be like, very careful while you're building. As such, how your perfection actually, then it will give you the results. If you are giving lethargic actually, then you don't know what is it, So make it sense from the modeling just to be like, in a bit of concept oriented. Then afterwards, actually, khalas, take the results actually by trustworthy. You get a point. Now you cannot trust. You get a point. So in order to get trust, you are doing all those things. Go to the plan directly to the base. Yeah. Base, yeah. Make sure CLR is always deselected, boss. CLR is always deselected. Make sure, yeah. Whenever you are going to select something, make sure CLR is deselected. Now I'm going to select all the points. Yeah. Base. Support. Now I'm going to give you the support. I don't know what support it is. I don't want to spend time actually to look at the support. I'll go directly assign, joint, restraints. Yeah. Can you see there are like 4 supports is there. First one is showing the symbol is called what? Fixed. Fantastic. Second one is pinned actually. Simply supported. Third one is roller. Fourth one is hinge. Okay. So what you're going to use it either fix or pinned actually. Since it is a high-rise building, actually, you know that entirely like, either it will fall raft foundation or pile foundation. Okay. Only for isolated actually, which will be like, G plus 1 villa, G plus 2, right? Actually, the soil is good. You'll go for isolated foundation. The reason why you're going for isolated foundation, so you'll go for like, pinned joint, simply supported, because you don't want to increase the foundation size. If you're going for simply supported, you will never have the moment actually. You don't have the moment and foundation size will never be bigger actually. If you have the moment, then stress equal to P by A plus M by Z. Remember actually, this M by Z. This M by Z is the term which you're going to increase your foundation dimension. If not, stress equal to only P by A. You're getting a point actually. But for high-rise building, you don't need to worry about because since it is a raft, it is the entire is called finite element. Even the moment is there, whole plate is going to be act as a moment. So there won't be any kind of overturning. But when you're talking about the individual foundation, actually, the overturning will be very critical. Because the individual foundation as a piece of cake, 2 meter by 2 meter, 3 meter by 3 meter, 6 meter by whatsoever it is, the dimension which is going to be resist the overturning moment. This you will have a problem in your. I'll just give you the best example because some of the people are from the contracting people actually. The crane foundation. When you're designing the crane foundation, okay, there is a huge moment is there, right? Huge moment. It's not like 100, 200, 2,500, 2,000 kilonewton, 3,000 kilonewton meter with respect to the height, right? Yeah, fantastic. Now what happened? These moment it need to be resisted by what? Foundation. Most of the consultant they will never allow you to like to correlate the foundation or to interact this foundation to the raft. They'll ask you to like 60% of consultant they will ask you to design the individual foundation right below the raft. Point. No. I cannot connect actually. I cannot take my foundation. I don't want to do your reaction on my ref. So you do it independently. Actually. So what you will do? You will do your foundation below the raft. Correct? There are some consultant with slow, very practical way actually will take the reaction or will give you the safe model and you apply the reaction, check if there is any extra reinforcement is required, propose it. It's very rare concern. Some of the consultants, what they should do, they don't want to take a responsibility. They will say, no, you design your individual foundation. Then after your 6 meter by 6 meter or 7 meter by 7 meter foundation of crane is need to be resist the entire movement. That is the reason you will have a massive depth. It's not because of the, what do you call, the vertical force. The vertical force, it might be required only 700, 750. Okay. But when you're going for the moment, actually, it required 1.2, 1.4, 1.5 meters. That's the reason the crane foundation is always not less than 1.4. It will pass 1.2, 1.3, but due to the, what do you call, the crane constraints, we need to just embed one mast to the downwatch. Okay. Like half of the mast. And to support half of the mast, I need the leg. The leg to be 700 to 750 millimeters. You get my point. So, which is almost 1.4 to 1.5 meters in the bound that actually we need to go for it. Okay. So what I'm trying to say, this overturning moment is always very critical when compared to what we call the compression, when compared to direct tension. Okay. Direct tension is what someone is lifting you. Overturning moment is what someone is hitting you on the head. Actually. When someone is hitting you on the head, actually, then the two legs is going to resist the moment. Actually. Very important. Yeah. Okay. Go for fixed. Okay. Sir, for isolated, can I go for fixed? You can go for it. No problem. It's up to you. You can go for any support. But the consequences, what I'm trying to say, this is what you're going to have. Okay. And you don't need to bother about for the G plus 1, G plus 2 and all, worrying about the lateral force. Because it will not govern this. There is no mass. You get a point. But when you're going for the building is higher, then it will have a problem will having a lateral force in terms of displacement, in terms of drift. Fantastic. Now go for define load patterns. Load patterns. Type wind. Wind. Yeah. Then change to wind. Yeah. Then change to A.E.X.L 722. Whatever the latest version is there. If you do have 16, use it 16. No problem. Maybe I do have 21.2 in this version. Which version you do have, choose it. No problem. Doesn't matter. From 16 onwards, it is same. From A.E.X.L 716 onwards, it is same. Boss. Only 5 is different. I told you already the combination different. Add new load. Yeah. Consider whenever you're going to add the lateral force, you need to give the parameters and coefficient. Okay. Yeah. So go to modify lateral load. What is the wind speed? 38 meters per second, which is equal to 85 miles per hour. Huh? Same. Huh? Okay. Exposure type, I'll make it in a very simple way. It shows 3 exposure types, right? B, C, D, right? Okay. We'll come from the last. What is D? D is nothing but the building is located where all the 4 sides is open. All the 4 sides is open. It is not necessity building is need to be located in coastal zones. Huh? It can anywhere. Even in business, if you're going to build it, actually, if there is no structure adjacent to it, actually, it's all roads, it is all 4 sides is open. Coastal zone at any cost, it is also 4 sides is open. What is C? C is nothing but actually 3 side open, 1 side close. What is 3 side open? Again, you don't need to go for coastal zone. If one building to another building, if I have a road for 5 lanes, actually, then it is open. Because the building is, when it is closed, actually, when my proposed building to adjacent building is being touch, or it's only gap of 50 centi, 1 meter, 1.5 only for the setback, then wind force will be less. Okay. But if you're talking about 2 lane, 3 lanes in the road, actually, then it is a free flow of wind. You're getting a point. That's what is called as open. Actually. Don't consider open. If there is a road, The best way which I can say, it is a road. If there is a road, either it is 2 lane or 1 lane, doesn't matter. If there is a road, it is called open. When the building is touches with the setback actually, then it is called close. It considers less wind actually when compared to this. You don't need to go for D. D is straightforward, is very clear. All four sides is open. When you make sure it is D, okay, but don't go for a conservative D. Some people will say, no, I don't know, but I'm designing for D. Why? Because you're living in Dubai, you know everywhere. Even you can keep it in the Google map, actually see it in 3D. They get a point actually. What is adjacent? You can go and you can visit it. But if you're designing from third country, like some other country, which you don't want to take a risk, then you can go for D. Somebody is not giving the proper information. Okay, but mostly we will go for C, not to take a risk. D is what? Two side open, two side closed. Two side there is a road, two side there is a building which is closest to it. Say, no? Okay, so go for C time being. Ground elevation factor, topographical factor is always is correlation. Topographical factor, ground elevation factor is nothing but what? Whether the building is located in the ground or it is located in the hilly areas, in mountain areas, then my elevation is different. Okay, my topographical is different. You getting a point? Even if it is different, you cannot assume. Okay, you cannot assume. It has to be come from the geotechnical people. Okay, there are two kind of report. One is called geotechnical report. Another one is geophysical. Geophysical study. Geotechnical study, geophysical study is different. You know that, right? Yeah. What is the difference actually? Geotechnical and geophysical? Yeah, resistivity, shear strength actually. Because geophysical, to carry out the test is also different actually. Because they will connect to the system. They'll go for what do you call wires on top of ground actually. They'll see what is the shear wave velocity, if there is any cavity, if there is any liquefaction actually. So which is purposefully it's not about the chemical properties or chemical properties. You are taking the sample and going to the lab actually testing it, what it is. That is the chemical properties you're taking. The one which you're doing SPT test actually, right? But the one geophysical is what actually checking the shear wave velocity and kind of things. You get a point actually. Shear wave velocity when there is low, when it is called liquefaction. You know liquefaction, right? I already told you. Liquefaction. क्या बोलते हैं हिंदी में दलदल बोलते हैं ना? Liquefaction. Yeah. I don't know about Malayalam. In Tamil actually they used to call. Yeah, there's no liquefaction in the sense actually I can give you the best example. I mean, huh? Yeah, I mean, what do you call? Podakuli, huh? Podakuli, yeah. Huh? Yeah. Podakuli. Because yeah. I'll make a funny actually. I don't know you people not watching Tamil movies. Yeah, in Tamil movies actually there is one in Mohan movies is there, right? Actually, okay. There's the actor actually which goes to the forest, okay, while singing the song. There is found in the what do you call this liquefaction, and she will just suddenly fell down. Actually, you're getting a point because it automatically grabs. Liquefaction is the soil actually. It will automatically shrink. It will take the object. It will shrink. Any object it will shrink. Okay, liquefaction is the one actually which is the worst case. It is recommended, it is not advisable. There are two things. Okay, and it is not recommended also. It is recommended in the sense you do have some kind of solution, you can go for it still. It is advisable in the sense actually still you have some solution you can go for. It is not recommended in the sense you don't have solution at all. Liquefaction, wherever you found, you don't have any solution at all. Until to remove all the liquefaction soil. Until to remove. Sir, I don't get any kind of scenarios. I'm building on top of liquefaction. You will never get it until otherwise if the seismic comes. If the seismic comes actually, the shear velocity of the soil is too low. Actually. Immediately what will happen? I mean, it will collapse. Immediately. In a matter of seconds actually it will collapse. That's what has happened in Turkey. In Turkey, so many buildings when it has been it is impact actually. If you see again, go and see the photos, so many buildings without having any cracks, the building has toppled because of the liquefaction, because they did not test it. It's like traditional how we used to build in India for G+1, G+2, G+2. We'll never test the soil, right? If you're going for high rise actually, and then a big company, they will test the soil. Nowadays, people are very smart. Even G+1, G+2, they are just spending the, like, what do you call, money to test the soil. You're getting a point, not to take a risk. Okay. So going here, actually, the E1, E2 is called eccentricity. Eccentricity is what actually? I'm assuming the wind which is acting from X 15% actually away from this. Y 15%. Additional eccentricity I'm considering. Yeah, additional eccentricity. Here, parapet. Okay, parapet. Especially for the wind, exposure height, it's not from the base. It's from what? It's from ground floor. Yeah. Whenever you do have a basement, actually, you should not consider because wind is only like acting whatever the structure which is exposed. And there is a basement, it will not have any impact. Nothing. Zero movement. Zero movement in the base. Seismic is not like that. Seismic, you need to consider everything. Yeah, parapet. Parapet is interesting. Parapet is up to the, what do you call, contractor. And if the designer having experience, actually, he can decide. Up to 1.2, 1.5 meters. Okay. Most of the contractors, actually, they will go for block wall, right? Actually. 1.2, 1.5 meters. If in case, if you decided even for 1.2, you want to go for concrete wall, then you have to consider. Because the double bar comes from the slabs. Then what will happen actually? The additional 1.2 meters when the lateral force is acting, additional moment is created. Now I'm considering the height till the roof, right? Actually. Okay. So till the roof, say for an example, it will be 60 meters actually. So my parapet is 1.5 meters. Then I need to consider 61.5. Then wind will be little more. Okay. Usually we used to avoid this 1.2, 1.5 meters actually, mostly because we consider they will go for like, block wall. If not, if you decided actually, then it is comes from the double. Now I'll go for even 1.2, then you have to consider. You have to consider. Yeah. Okay. It's up to us, sir. It's up to us. Even it is not from DM actually, will never force you. Up to 1.2, it is okay for them. Even they will never ask you. But if it is more than 1.2, mostly like they will go for concrete work. 100 mm, 125, 150 mm wall. Okay. Okay, yeah. Then go for seismic EQ.X. Automatic. You have given the code, right? Windward coefficient, leeward coefficient, automatically it will take it. I know what you're asking. Very good. EQ.X. Yeah. EQ.X. Seismic, not seismic drift, only seismic. AC, same code. The one which you selected for wind, actually, it is the same code. Add new load. Yeah. Then modify lateral load. Yeah. You added the cases for EQ.X, right? So remove all y direction. Yeah. We are keeping only x direction. Now, this is the question actually. So, do I need to consider eccentricity or you don't need to consider? When you're designing for G+5, 6, 7, actually, you don't need to consider much eccentricity. But when you're really designing for high-rise building, actually, you need to consider extra eccentricity. This is mandatory from the authority. You cannot avoid it. Now, eccentricity, how much? It is 5%. Yeah, 0.05 is nothing but what? 5%. Now, here, what do you call? Yeah. Here, these are standard actually, which we have discussed in the DBC code, right? Okay. I don't know whether I do have a DBC code here. Anybody has? I gave you, right? It's not there. But anybody has, open it. Open it, open. Anybody has, open it. Yeah, here program calculated CT 0.02 for concrete structure constant. Remember, for time period T equal to CT HN over of 3B4. CT value is 0.02. It's not 0.028. When you scroll down, you will find 0.0. Select 0.0. Who has scored? DBC. How much? Yeah, SS is how much? 0.51, right? Okay. 0. S1 0. कितना है यार, वैल्यू कितना है मेरे पास नहीं है। हाँ 0.18 राइट, उसमें SD1 है भाई। हाँ SD1 नहीं है पक्का। ओके SD1 डालो, मैं बताता हूँ, डाल दो। इट इज इन DBC कोड। ओके लॉन्ग पीरियड कितना है भाई? 24 seconds, वेरी गुड। Site clause here, site clause A, B, B, C, 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 D is there, right? Actually, this is what it is. This is with respect to the soil type. Hard rock, rock, okay. What do you call dense soil, very dense, but you cannot assume. This is from the geotechnical book. You cannot assume. This is, I'm just giving an example actually, but you cannot assume. You cannot assume. No, ma. Can you see here? Yeah, this one. Yeah. Can you see here A, B, C, D, E? Yeah? Say hard rock, rock, very dense soil, soft rock actually. Yeah, these are the one actually. Okay, I'll go for C. First value SS कितना? 0.51. S1 कितना है? 0.18. C, side plus C. SDS is SS is it automatically calculated, no? How much SDS? Next value, what is it? Okay, 0.444, huh? Okay, 0.44. Because if you're using lower version, automatically it will calculate. मैं अभी दिखाया ना, ये soil, dense soil. C. It is there in the geotechnical. We cannot assume. Okay. पक्का रहेगा 100%। check 100%. Only they make us. It has to come from because they were the one actually who did the soil test, right? Who could be left, I mean, like, you know, more actually took the sample. They were the one that what is the soil classification?
Medium dense to medium dense to the medium dense.
0 to 5. So 5 to. So what are we? Yeah, it's okay, right? Yeah. The response modification is not changing. What is the value of the response to R value to what is the R value? DBC group WhatsApp. Correct. DBC code नहीं डीपीसी को डाल ना वो भी बता भाई डीपीसी को ओपन किया ना वो ग्रुप में डालो इमीडिएटली
कौन सा पेज?
नहीं वैसे ही डालो ग्रुप में पूरी कोड डालो पूरी कोड ग्रुप में डालो मैं ऐसे नहीं हूं बताता हूं मैं ऐसे नहीं हूं काम Some 16. Can that be? That is. Okay, bro. Upload. That is. I think I'm also beginning. या कौन सा पेज नंबर कौन सा है वो
स्ट्रक्चर में लास्ट में
हां
स्ट्रक्चर किराना लास्ट में
स्ट्रक्चर बताइए हां F10 है
Sir, F63 में रिपीट फंक्शन का पूरा सेक्शन है
यार F10 नहीं है यार अभी तुम देख लेना चाहिए मैं बल बताया
F7. F7.13.
40 and 40. Page number 40.
Page number there.
40. 40.
Part F 40.
Do an acceleration parameters seismic achieve. SS will be 0.5. Okay, S1 will be 0.18. And the A is 722 is different 0.18. Okay, 0.18. 24 seconds. Okay, cross one soil profit. Automatically, then calculate. Okay, okay. அதுக்கப்புறம் இன்னொரு recall. இல்ல ஒரு 5.5 தான் 4.5 யூஸ் பண்ணிக்கலாம் 4.5 முஸ்கில் ஆமா நீ 4.5 யூஸ் பண்ணுமா because you have so many columns are there. See, I'll tell you the difference. Shear wall system is 5. Okay, pure column frame system is 4. The column and shear wall together is 5. 100% correct. But in recent DM actually they want us to go for 4. Okay, you can still use it 5.5. I don't want to confuse. Still you can use it 5. No problem at all. Okay, but use it 4.5. Okay. Yeah, occupants importance factor is 1 actually. Omega is 2.5. Deflection amplification factor is how much? I need to check in the code. With all though, we'll check it in the code. We'll check it in the code. With all though. Yeah. Then okay. Similar way, you need to create EQY as well. No. EQY again, you need to enter all those things. Yeah, there is no option. Base. That don't need to change.